One of the main challenges for product and service design research is getting access to real-life users. It can be expensive, takes up a significant amount of time to recruit, schedule, organize, can also conflict with other team priorities. And even if we can check all the boxes and do get our hands on these users, we can only pray to be able to do a follow-up with them, which 9 times out of 10 is critical for proper research. Well, what if I told you you may actually not need these users at all, and you would still be able to extract insights and breakthroughs to aid your design process? Well, that's exactly what a group of scientists are researching in the field of generative AI. The paper that I want to discuss today is called Generative Agents, Interactive Simulacra of Human Behavior, that goes a little deeper on this topic. Before we get into the details of this AI research paper, let's get on the same page on the definition of an AI or generative agent. So referencing this particular article, slightly paraphrased, generative agents are able to take their current environment and past experiences as input and generate behavior as output, creating believable, human-like behavior in individual and group contexts. So basically a group of scientists, most of them from Stanford, put 25 interactive agents into a video game-like simulation. Each agent was implanted with a seed memory, essentially a long paragraph that provided basic details about who they are, who they know, and their general interests. But where things get interesting is that out of the 25 agents in this study, only 2 were prompted with a specific agenda. The first one was Sam, Agent Sam, and he was instructed to run for mayor. The second one was Isabella, and she was instructed to organize a Valentine's Day party. The study lasted 2 days, and the researchers then interviewed the agents not only to determine how well they could remember things, but also their ability to draw conclusions from those memories for hypothetical situations or future planning. They also recruited human participants who would be given access to the agent's entire memory stream and then asked them the same set of interview questions. So what were some of the key findings from this research? Let's start with the agent's performance. With access to all of its memory banks, observation, planning, and reflections, the agents performed much better than the human evaluators, meaning their answers to the interviews were more believable and consistent with the actual memories and events from the simulation. The answers from the agents were not perfect though, sometimes embellishing answers with added details that were not present in the model's actual database, or answering questions that reflected an incomplete or fragmented retrieval of their memory. From a big picture analysis point of view, the researchers measured 3 areas of social behavior that emerged from the study. Information diffusion. If there was important information, were the agents able to spread it among themselves? Well, here's the evidence. Out of the 25 agents, 32% knew that Sam was running for mayor. 52% knew about Isabella's Valentine's Day party. Relationship memory. Were the agents able to form ties with each other over the course of the simulation? Out of the 453 agent responses regarding their awareness of other agents, only 1.3% were found to be hallucinated. Further, they used those agent responses to form a network density graph, which yielded a 0.74 out of a 0 to 1 value range, indicating a relatively high level of interconnectedness among the agent community. Coordination. Were the agents able to coordinate with each other and organically form group activities? For the Valentine's Day party, for example, it was found that 5 out of the 12 invited agents actually showed up to the party, a little over 40% participation rate. Now, real quick, let's understand how this technology actually works. All of the agent's observations are recorded into a large database which is comprised of 3 main components. Memory stream, essentially a large database that records in natural language all of the agent's experience. There is a memory retrieval mechanism that ranks each memory by relevance, recency, and importance to guide the agent's moment-to-moment behavior. Reflection, which synthesizes memories into higher-level inferences over time, enabling the agent to draw conclusions about itself and others to better guide its behavior. The third one is planning, which takes these reflections and the current details of their environment to help the agent form high-level action plans that also takes into account their past experiences. All of these memory banks are dynamically updated over time as new memories are synthesized with older memories, as well as the reflections generated by the agent. This kind of architecture deviates from today's current state large language models like ChatGPT that have a limited context window and function on the basis of first-order prompting. So now, on to the fun stuff. How can this technology be leveraged for service design research? As shown in this paper, scientists were able to document 3 areas of human-like social behavior: the ability to spread important information, the ability to form relationships and network in a social environment, the ability to coordinate group activities. Well, these are all baseline ingredients that make up the inner workings of any service delivery process. A group of teams or functions sharing information, scheduling group activities, and coordinating with each other to achieve desired outcomes within an organization. So I've identified 3 scenarios where this kind of technology can be leveraged to stimulate service design research. First, employees versus employees. This is probably the most obvious one because it mirrors many of the existing characteristics of the agent simulation that I described, but with a few distinctions. Instead of calling them agents, we would call them what we reference in service design as actors. The town Smallville would instead be an office or some kind of workspace. The initial seed memory would take the form of a job description. The initial prompts would be designed in a way to inform the agent of a task or assignment. This type of simulation would provide rich insights as to how teams would cooperate and share information that could be internalized as best practices or used as documentation for change management efforts. Second, customer versus digital user interface. In this type of simulation, the agent would be the customer and the main point of interaction would be through a piece of technology. Let's say a kiosk at a bank. In this simulation, the kiosk would be primarily a chat interface, and the research insights would center around the conversational components on that specific service interaction. Third, customer versus employee. Now, in this scenario, we combine the best of both worlds, where the employee agents interact with the customer agents in a physical location, like let's say a bank. In this context, we can analyze the interactions between an associate and a customer through a wide range of situations and circumstances to essentially shock test the service delivery model and address the gaps that might otherwise never surface on a team's radar. All in all, this kind of technology has the potential to provide rich insights in product, service design, and market research. The value creation from a business point of view are the following: mitigating risks with deploying new features and capabilities or new products and services entirely, reducing the cost of market or product research from not requiring human participants in the process or facilitators, accelerating the pace of innovation, transforming companies into vision-led organizations. Fingers crossed. What do you think? Are AI agents going to take over the world, or am I just hyping things up? Let me know in the comments, and thanks for watching.